করুন। আমাকে এনেবল করে দিন স্ক্রিন শেয়ারিং এর জন্য।
Yes sir, done sir. Done sir. Please you can start.
দেখুন তো যাচ্ছে?
Yes sir. It's coming sir.
Okay. So at the beginning I started with the discussion of agent technology, agent multi-agent system, and I told that how agent technology come into the picture from traditional computing system to agent-based system, the autonomy, independence, autonomous task delegation that we have discussed. We also discussed how agent technology is different from object-oriented technology or function-oriented programming, and also discussed how agent technology is different from traditional AI technique and the relation between multi-agent system and distributed system. After those discussions, I told that I will be discussing two research areas where for the last couple of years we have been working with my PhD student. So one of the area that from day before yesterday to yesterday I discussed that was DCOP, distributed constraint optimization. So typically we have used DCOP or the modification of DCOP algorithm for scheduling of different type of transportation problem, disasters management in railways and all. And now another research component of multi-agent system that also we are working for the last couple of years, that is coalition structure generation. So multi-agent based coalition structure generation. So today I will be discussing with how multi-agent system is used for coalition structure.
Please mute your mic, please everyone, mute your mic.
So how multi-agent system is used for coalition structure generation, how coalition structure, why coalition structure is needed, and the research challenges of coalition structure generation. So that I would be discussing, and still what are the open challenges still exist in coalition structure generation where people can start working. So that I will be discussing today. So here two of my PhD students, one is Narayan Chandar who completed this year his PhD on coalition structure generation on multi-agent, and another PhD scholar Samriddhi Sarkar, she is working on coalition structure generation on heterogeneous environment. So she is working for the last 2 years on this topic. Okay, so I'm not going again with the what is agent and multi-agent system, etc., because this already we have discussed. So I'm done.
Please mute your mic. Shahid Ansari, please mute your mic. Sir, one option is there with you, that is mute all. One option is there.
Let me
mute all.
Mute all more. Mute all.
In participants list.
Participant
list.
হ্যাঁ মিউট অল।
মিউট
আপনিও মিউট হয়ে যাবেন তো, আপনিও মিউট হয়ে যাবেন।
কোনো অসুবিধা নেই স্যার, কোনো অসুবিধা নেই স্যার, নট অ্যান ইস্যু।
ওকে। Okay, so I'm directly starting with the multi-agent coalition. So I start with a very basic example of coalition structure generation, which is related to your area. Ramgarh Engineering College was started by Jharkhand government initially, and as far I know that the total infrastructure is developed by Jharkhand government. But due to some issues, they collaborate with another academic organization called Techno India to run the college at Ramgarh, Jharkhand. So here if you see, there are two parties. One is the Jharkhand government or Jharkhand Education Department. Another is Techno India. These two organizations collaborate with each other, or we can say they form a coalition to achieve some common goal. What is the goal? The goal is, of course, from Techno India's perspective, the goal is profit making. From the perspective of Jharkhand government, to establish an educational environment in their state, or higher education environment in their state. But why they collaborate? There are some issues for collaboration. Jharkhand government, they have a land, they have an infrastructure, but they may not have that much of knowledge of running an engineering college. But on the other hand, Techno India, mainly based on West Bengal, they have a lot of expertise, particularly in education sector, higher education sector. But if they want to expand it from West Bengal to other state, they don't have any place or infrastructure. So what they did, Techno India and Jharkhand government, they collaborate with each other and they form a coalition. They form a coalition to establish a engineering college. So basic infrastructure is provided by Jharkhand government. The day-to-day running cost is being, and the administrative part, the academic administrative part is being taken care by the Techno India group. So in this way, both the parties are going to be benefited. That is the main objective of coalition formation. So here, as we find, there are only two parties for this particular example, the Jharkhand government and the Techno India group. So the computational complexity is very less. But when you think this number is huge, that means the participating or collaborating parties are huge, then just joining hand will not serve the purpose. There will be a lot of computational overhead. So that we will be discussing what is the, from the computer science perspective of view, where is our work to do. So what is coalition? A coalition is a set of agents that work together to achieve a mutually beneficial goal. As I said, a coalition is a set of agents that work together to achieve a mutually beneficial goal. Why agent join in coalition? Because cannot complete its goal alone. Here, the Jharkhand government cannot complete its entire goal, or neither the Techno India can do it. So they form a coalition. So why agents join in coalition? Cannot complete its goal alone. Wants to complete its goal faster. Sometimes it happens, if I work alone, it takes 1 hour to do a job, but if I collaborate with somebody, then the time will be less. So we want to complete its goal faster. Wants to make more profit to maximize system outcome. It is found that sometimes it happens that if an agent works alone, it gets a profit, but if it collaborates with somebody else, some other agents, then both of the agents' profit will be maximizes. So they want to make more profit. That's why they collaborate or coalition, and they form coalition. So this is a typical picture of coalition. So there are a lot of applications for coalition formation. Distributed sensor network is one of the applications of coalition formation. Sensor can make coalition and work together to track target of interest. So if there is one or more than one targets, so more than one targets cannot be tracked by one sensor. As I have given the example in last class also with the DCOP, that there are sensor and there are target. So one sensor cannot track the entire targets. So a sensor may form some kind of ad hoc team. Those who are familiar with the term ad hoc network, they will form some kind of ad hoc team, which is nothing but forming the coalition. So coalition, what is the coalition? Forming the coalition among the sensor to track some particular targets. So their goal is to track maximum number of targets. That is their goal. Distributed vehicle routing. Nowadays, it is a very common phenomena that some e-commerce company is selling the product online, but they are forming coalition with some courier company to deliver the product at your household. So the actual organization is different, who is selling the product, but who is distributing the product is something different. For example, Flipkart and eCart. Flipkart is a separate organization, eCart is a separate organization. Similarly, there are a lot of e-commerce companies who are going to collaborate, forming some coalition with the delivery companies. Sometimes the delivery companies, they have a delivery from one city to another city. So they form kind of coalitions to maximize their profit or minimize their cost. So to reduce the transportation cost. Distributed vehicle routing. For a large city where the traffic is very huge, for example, Bombay, Bangalore, but the traffic is very huge, so that if all the vehicles move on the same street, then it will be a huge bottleneck. So what can be done? These vehicles can form some kind of coalition to maintain an ad hoc route such that everyone will feel or everyone will face minimum congestion on the road. This is very common in India. Several political parties cooperate when no party on its own can achieve a majority in the parliament. This is a very common. So I think every citizen knows in India that to form the government, a political party needs to have the winning seat more than 50% of the total number of parliament seats. But earlier it was very common that no political party is getting more than 50% seat to form the government. So what they did, they are collaborating with some other party. That's called alliance. NDA is an alliance. UPA is an alliance. So one political party form an alliance with other political party, and they are forming some kind of team such that their majority will be more than 50%, such that they can claim to the president that we want to form the government. So forming the alliance, they can achieve the majority to form the government. So it's a very common phenomena in India. This is another area where, as I said, that some delivery companies and e-commerce companies, they are forming coalition. Here, coalition of companies and associations seeking address. E-commerce company, as I said, Microsoft is forming coalition with Flipkart. Microsoft is providing the cloud services, and Flipkart is a e-commerce company. So while expanding their business, Flipkart join hands with Microsoft. Microsoft gives the support of cloud services. On the other hand, Flipkart takes these cloud services and use for their e-commerce delivery, e-commerce services. So these two companies are entirely separate company. Their administration are separate. Their profits are separate. But to expand their business in India, Flipkart join hands with Microsoft. Okay, So this is all about the basic idea of coalition, some of the applications areas, some of the real life example of coalition formation. Now I will be going to the computational complexity of the coalition formation, typically where we, the people from computer science, can work. Let us assume there are three agents. There are three agents, A1, A2, A3. There is called characteristic function game G, which is defined by a pair n, v, where n is not a null, is a number of finite agents or player participating in the game, and this is a function 2 to the power n that gives a real value, is a characteristic function which maps each coalition C to a real number. Let us take an example. We have three agents, A1, A2, A3. There are three people. What are the possible coalition that can take place? A1 can play alone. A2 can play alone. A3 can play alone. A1 and A2 can join hands. A1 and A3 can join hands. A2 and A3 can join hands. A1, A2, A3 can work together. So these are the possible combination that these three agents, A1, A2, A3, can do. For example, Jharkhand government can run their college at Ramgarh without any disturbance. Techno India is, as usual, running its colleges in West Bengal. So they are separate.
Sir,
while in Jharkhand, they are forming coalition, A1 and A2.
Sir, one question I have.
Either, yeah, sure.
Sir, you are telling, sir, where n equals to not null. That means one agent can be a pair. Single.
Yeah. Yes. তুমি কারোর সঙ্গে করতে চাইছো না কাজ, তুমি একা কাজ করবে।
Single agent can be player.
Yes. So these are called coalition. So A1 is a single agent coalition. A2 is a single agent coalition. A3 is a single agent coalition. A1, A2, two agent coalition. A1, A3, two agent coalition. A2, A3, two agent coalition. A1, A2, A3, three agent coalition. So that's why n cannot be null, because we cannot take 0. That means we cannot take a coalition where there is no agent. Am I clear?
But yes, sir. But actually, when you are telling the coalition thing, and coalition happens only when two agents are coming now.
Okay. Yes.
That's why I am asking, sir.
Yeah. So this is called coalition, and forming group will be called coalition structure.
Okay.
So this is coalition, and what are the possible coalition structure can be formed, that we will be discussing.
Okay, sir. Then
তুমি দেখো, তারপর যদি না বুঝতে পারো, I will repeat again.
Okay,
no
sir.
problem.
Okay, sir. Not
Please feel free to interrupt me at any moment of time. Okay, I'll be happy.
Okay, sir.
So for example, if A1 works alone, the payoff is 20. That means the profit is 20. If A2 works alone, the profit is 40. If A3 alone works alone, the profit is 30. If A1, A2 works together, then the profit is 70. See, if A1 works alone, the profit is 20. If A2 works alone, profit is 40. So the total profit is 60. So what do you think? They should work separately or should form a joint hands? Obviously, they should form joint hands.
Yes, the joint hands.
Sure. But A1, A3. If A1 works 20, if A3 works 30, the total value is 20 plus 30, 50. But A1, A3, if they works together, joint hands, their profit makes 40. So they will not form coalition. Because if they form coalition, if they join hands together, then their profit is decreasing. Their profit is decreasing. Similarly, if A2 and A3 works together, then the profit is 65. But here, if A2 and A3 works together separately, then the profit is 40 plus 30. So they, of course, they will prefer to work separately. Similarly, if A1, A2, A3 work separately together, the total profit is 95. On the other hand, if they work together separately, A1 separately, A2 separately, A3 separately, then 20 plus 40, 60, 60 plus 30, 90. So they will prefer to work together. So this is given. Now this is called the coalition. This is called the coalition. And these values is called the characteristic function. So there will be some kind of function. There will be some kind of function that maps each coalition to a real values.
So,
Each
how this variation occur? Because when we are adding A1 and A3, it is coming 50. So how 10% it is decreasing?
You have a very good friend in your batch. You know, if that person in your group in the lab, your lab performance will be definitely increased. You know. On the other hand, you also know that there is a person in your batch with whom you don't have very good relation. Rather, you have a very bad relation. If somehow your HOD put you in the same group in the lab, then your performance, instead of increasing, your performance may decrease. So it is the situation with whom you are forming coalition. Bolo, am I clear?
Yes, sir.
Bhaskar, is it okay?
Sir, yes, sir. Very good example.
Yeah.
Yes, sir. Nothing, sir.
Okay. So now here you can from the binary values A1, A2, and A3, there can be 2 to the power n, that is 2 to the power 3 number of possible combination, but one combination is 0, 0, 0. That we will not take. So if I say A1, A2, A3, the values can be 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0. So you will get 2 to the power n, 2 to the power n number of combination. But here the combination 2 to the power n minus 1 number of combination, because we are not taking the combination which consists of no agent. Okay. Now, so this characteristic function is given, which maps each coalition to a real value. A1 maps to a real value, A2 maps to a real value, A3 maps to a real value, A1, A2, if work together, real value. Now, our objective to find out the coalition structure which gives maximum profit, maximum payoff. The possible coalition structure for 3 agents are, see the example. Where, so the difference between coalition and coalition structure, in coalition, there can be any number of agents. And coalition structure, all agents will be there. They may work together, maybe in a different format. So A1, A2, A3 can works separately. A1 separate काम किया, A2 separate काम किया, A3 separate काम किया. There may be a possibility A1, A2 works together, A3 works separately. There is a possibility A2 works separate, A1, A3 works together. There is a possibility A1 works separately, A2, A3 works together. There is a possibility A1, A2, A3 all works together. Clear? So if we want to find out the value for this coalition structure, A1 works separately, A2 works separately, A3 works separately, what will be the value? Can anybody say? The student who asked this question, can you tell me what will be the value for this? I think Neha Kumari or somebody asked me the question.
Sir, they will work separately, then the value of A will be 20, means it will be distributed whatever the actual value is there.
Yeah, so what will be the total value?
20 plus 40 plus 30, 90.
Right, 90. What will be the total value for here? Can anybody say?
Sir, 100.
Why? Because this
A1,
is 70.
A2, 70 and A3 is 30. So 70 plus 30.
Good, good, very good. What will be this?
80.
Yes.
So what should they do? We want to get that coalition structure which gives maximum profit, maximum output, maximum payoff. So we want to get this. So this is the coalition structure which returns the maximum value. So the idea will be A1 and A2 will work together and A3 will work separately. A1 and A2 works together and A3 will work separately. So we will discard this coalition structure. Is this idea clear?
Sir, very clear. Very clear too. And sir, my question is also there. That thing.
Clear?
Okay.
So,
okay. Yes.
So there is coalition and coalition structure.
Yes. Yes.
This one is coalition and this is coalition structure.
Structure. Okay, sir.
Okay, where all agents will be there. Maybe in any form, but they will be in each structure, all agents will be there.
Yes, sir.
Okay.
Okay, sir.
Now, the problem is for three agents, the coalition structure, getting this coalition structure 1, 2, 3, 4, 5. If you increase the number of agent, the number of coalition will be increased exponentially and number of coalition structure will also increase exponentially. And that leads to as an NP complete problem. Clear? From the algorithmic point of view, if you increase the number of agent, the number of coalition will increase and huge in exponential growth, and number of coalition structure will also increase in exponential growth. And we tested for 27 agent. If we have, instead of 3 agents, if we have 27 agents, if we have 27 agents, it takes 3 days to compute the coalition structure, which gives the maximum profit in normal computer. It takes 3 days to compute the whole thing. The growth is so high. Okay, so our objective is to find out some algorithm which will minimize the time complexity. That is the motivation behind the algorithmic side. The other research component or the other research challenges is how do you create this characteristic function game? That means how do you map a value within each collision? How do you map? For theoretical purpose, it is fine to show with a small example. But when you talk about a real example consisting of many number of agents, huge agents with lot of their constraint and profits, then how do you calculate this value? If Ramgarh, Jharkhand governments run Ramgarh Engineering College alone, what will be the profit? If Techno India runs a college in Jharkhand in area of Ramgarh, then what will be the profit? And if they work together, then what will be the profit? So before getting the coalition structure, you need to find out these values. And for that, you need to have a characteristic function game G. So designing the characteristic function for the coalition structure generation is typically a research problem. Because in real life, finding this function itself is a complicated task. Okay. So we want the coalition structure which gives maximum profit. That means we want the answer whether I should collaborate with you or not. Whether I should collaborate with you or not. Okay. So there are mainly three types of algorithms for coalition structure generation. One is exact algorithm, the second is anytime algorithm, and the third is heuristic algorithm. Exact algorithm always give you the best result. So the typical idea of this exact algorithm is dynamic programming, and the second is tree-based approach. For exact algorithm, if you remember the yesterday's discussion, for exact algorithm, you have to wait till the termination of the algorithm. You have to wait till the termination of the algorithm. But it is guaranteed that once it is terminated, you will definitely get the best result. That means the optimal result. That is the beauty of exact algorithm. But for exact algorithm, you have to wait till the termination of the algorithm comes. But for three agent, it is easy to see. But as I said that if the number of agents increases, for example, 27 agents or more than that, it takes even more than 3 days. And there are some situations in the real life where you cannot afford that much of time. You need immediate answer. You need immediate answer. So exact algorithm is fine when you have enough time to wait for termination of the algorithm and to get the optimal result. But for exact algorithm, you have to wait till the algorithm terminates. So you may not be able to give that much of time. The second approach is anytime algorithm. The anytime algorithm, you start in a point. In any moment of time, you can expect the result. The result may not be the optimal result, but you can expect a result. For example, yesterday also we have given the example for DCOP, the anytime algorithm for DCOP. That is the incomplete algorithms. You don't need to wait till the completion of the algorithm. Even in between the execution, you can take a result, and that result will be fine. So you have to trade off whether you want to get the optimal result. For that, you have enough time to give, or you don't have much time, you need immediate answer. So for that case, you can go for anytime algorithm. And the third is heuristic. So I'm not going to the survey of the existing. Okay, let us take the dynamic programming. So size 1 coalition. If you see my example, size 1 coalition, this is coalition C, which is given the coalition value, and we are doing the splitting operation, and we will be checking whether we will be going for coalition or we will be work separately. For example, from the example it is given, if 1 and 2 works together, their VC value is 50. You see the example. But if 1 and 2 work separately, their value is 70. So if they work together, the value is 50. If they work separately, V1 and V2, V1 and V2, 70. The result is 70. So what should they decide? What should they decide? They should decide to
Go separately.
they will work separately because they won't collaborate. Similarly, two sides coalition. If 1 and 3 works together, it is given as, yeah, somebody raise hand. Okay. Hello. Shubham, you can speak. Shubham Kumar, you can speak.
I think by mistake he has raised his hand.
Okay. Okay.
This basic mistake he has done regularly.
Okay, no problem, no problem. So if 1 and 3 works together, it is given the value is 60. Now we have to find out whether 1 and 3 will work together or they will work separately. If they work together, the value is given 60. But if they work separately, then we need to find out from the previous V1 plus V3. V1 is 30 and V3 is 25. So 30 and 25, 55. So the output will be, they will be working together and the value will be 60. 1 and 4. Similarly, it is given as 80. So if they work together, the value is 80. If they work separately, V1 and V4. So 30 plus 45, 75. So what they should choose? To work together. So in this way, you can find out the two sides coalition. Next, we will be coming to the three sides coalition. We will be coming to the three sides coalition. V1, V2, V3. It is given V1, V2, V3 as 90. V1, V2, V3. If they work together, it is given as 90. What are the other cases? Here there is a computation, lot of computation associated with it. If they work together, V1, V2, V3, the value is 90. So this is given as 90. The other possibility from this coalition, what are the different coalition structure could be there? V1 works separately and V2, V3 works together. V2 works separately, V1, V3 can work together. V3 works separately, V1, V2 can work together. So now let us compute this value. V1 works separately. The value is 30. Value is 30. If V2, V3, so V2, V3, what value should I take? Can anybody say? For this case, I need the value of V2, V3. V2, V3. Which value should I take?
So 65 we will take. V2.
Right, right. And what will be their option?
Sir, option is
They will be working
55 and 65. Both are of the option.
Both of them, but which option should I choose?
So 65 will choose. Definitely.
And that will, and they will be working separately.
Huh.
Okay, so V1 का value ले लो 30 plus 65, that is 95. Clear? Similarly, let us take this one. V2 and V1, V3. V2 value is 40 and V1, V3. And it is 60. So I should take 60. So 60 plus 40, 100. Similarly for V3. So out of this, all this thing, which one should I choose?
Sir, 101.
100, and that coalition structure?
2 and 1, 3.
2 and 1, 3. 2, 2 and 1, 3, because this combination gives me the maximum value. V2 works separately and 1, 3 works together. 2 works separately and 1, 3 works together. Clear? That gives the maximum profit. Next, similarly for 1, 2, 4. If they work together, 100. There is another option of coalition structure. V1 separately, V2, V4. V2 separately, V1, V4. V4 separately, V1, V2. And we will be computing from the previous. And that gives the result that if they work together, that gives the maximum. So we should not separate them. We will keep them together because they have a very good bonding. They have a very good bonding between agent 1, agent 2 and agent 4. These 3 agents have a very good bonding. So let us keep them together such that their total profit will be maximized. Okay, but as they have a very good bonding, if we separate them, the output may not be good. So that's why we will keep them together. That is the idea. Similarly for 1, 3, 4, similarly for 2, 3, 4, similarly for 4 size square, because we are taking 4 agents. This example is for 4 agents. 1, 2, 3, 4. It is given as 140. So mind it, this C and VC is given. In this example, C and VC is given. Now, how from C a VC is calculated, that is called characteristic function gain, which itself is a research component for a particular applications. Whether Congress will join hand with Trinamool or CPM, that gives that what will be their VC value. If they work separately, Congress works separately, Trinamool works separately, CPM works separately, then what will be their value? If they work together, then what will be their value? How they will calculate the value? How they will calculate the value, that depends on application to application, and that itself is a research component. So if somebody feels that I will be working on the characteristic function game, that itself is a research area, instead of going to this part.
So that can be applicable for minimizing also, na?
Yes, of course. Minimization.
Yes, minimum value we have to choose then.
Minimum value, you will be taking the minimum value, not the maximum one. So the simple idea, we are optimizing, right? So inside optimization, you have minimization as well as maximization.
Maximization.
If you go for profit, you will be considering
maximize,
the
yes, sir. Got it.
Right. So finding this value itself is a research component. As I said, that for parliament election, right? Whether from West Bengal, I am typically taking the idea of West Bengal. So whether Congress, CPM, Trinamool, maybe other local parties, whether they will be joint hand or not in against of BJP, that depends on what will be the values. So calculating the value itself is a very huge task. Maybe Trinamool may say that if this alliance is the winner and if they form the government, then we'll be taking the prime minister's seat. Will you be ready? So this type of negotiation among the agents can be there. If there are 50 ministers, then 3 ministers must be from Trinamool, 1 minister from, like this way. I mean, it's just an example, arbitrary example I'm taking. Okay. Now, if it's a 4-size coalition, 1, 2, 3, 4, this is given. Now we have to find out whether 1, 2, 3, 4 will be working together or they will be forming some kind of splitting. So 1, 2, 3, 4. 140, it is given. The other option can be V1 works separately and V2, V3, V4. V2 works separately, V1, V3, V4. V3 works separately like this way.
Here, sir, here we got 2 values. So 150 and 150 is this but
yeah, you can choose anyone. You can
anyone,
choose anyone.
Na?
Yes, anyone. Okay, so this is dynamic programming. Here you need to understand one thing. This is exact algorithm and this will give always the best result. Always the best result. And what is the result? The result is 150. And to get 150, this is the combination. Okay, and you see from 2, 3, 2, 3, 4, the best value is coming from this. From 3, 4, the best value is coming if they work together. For 3, 4, okay. So that means you have to take like this way. 1 will be working separately, 2 will be working separately, and 3, 4. So the final coalition structure will be 1, 2, and 3, 4. 1 separately, 2 separately, and 3, 4 together. Because this 2, 3, 4, you are getting the best result from here, and 3, 4, you are getting the best result from here. So the idea is 1 will work separately, 2 will work separately, and 3, 4 will work together. That gives the maximum profit, that is 150. So for dynamic programming, the idea is it will always give you the best result. But to get the best result, you have to wait till the termination of the algorithm. In between, in the middle of the algorithm, you cannot get a result. You have to wait till its termination. Third, for dynamic programming, we are reusing the existing values, mind it. We are reusing the existing values. Keno dag diccho go tomra ekhane?
Hey, anyone, please stop these things. This is very matter. Please.
I mean, is the attendance compulsory?
Not a source.
So why these people are attending?
Sir, please stop the screen again. Share the screen.
Okay, no problem. So here they are. I mean, dynamic programming is using the existing values. So whatever the previous value, that you have to keep in the memory, because we are reusing. Here to get the values of 2, 3, 4, we are using this one. To get the 3, 4 value, we are using this value. So all the previously calculated value must have to keep in your memory, in a computer memory. Otherwise, you cannot reuse. So one is the time, second is the huge value that you have to keep in the memory. So huge memory requirement will be there in dynamic programming. And you have to wait till the end of the termination of the algorithm. That is a drawback of dynamic programming. Now this algorithm has been modified by my student. they modified the dynamic programming with anytime dynamic programming. This is our paper. First, calculate the value of coalition A1, A2, A3, AN and separately, and select the better of these two as the initial solution. After algorithm completes kth iteration, it picks the largest value coalition of size I and its complement with n minus I. If algorithm stop prematurely, mind it, you don't need to wait till the completion of the algorithm. If the algorithm stop prematurely, that means you need answer immediately without waiting till the end. It still can return better of the initial solution and iterative solution. সত্যি এটাকে মুছতে হবে। দেখুন তো দেখা যাচ্ছে কিনা?
Yes sir, clear. Yes.
So here you see, this is our proposal. This is already given. Okay, this part, these two columns are already given in the example. I mean, in the problem. This is we are copying the same thing. Here we are calculating whether 1, 2 will be working together or they will be working separately for two sides coalition. After happening the two sides coalition, suppose you want to get the result. After happening the two sides coalition, you want to get the result. You don't have much time to wait till the termination of the algorithm. You don't have much time till the termination of the algorithm, or for your application, you need immediate answer. So what you will do, you will be taking for example 1 to 4 and its complement is 3. So take the best of 1 to 4 and 3. For two sides coalition, take 1, 3 and 2, 4. So in any point of time, you can choose and you will get the result of it. So you take, for example, you take 1, 2. The best is for 1, 2 is 70 and its complement is 3, 4. The best is 80. So you add 70 and 80. Should I repeat?
Okay sir, got it.
Yes sir. Yes sir.
I got it.
Once
Repeat once again. Okay.
I'm repeating. Yeah, I'm repeating. The first philosophical idea you need to understand, then it will be easy to understand this algorithm. The basic philosophy of dynamic algorithm is it is an exact algorithm and you need to wait till the termination of the algorithm. You cannot get in between result. While the algorithm is running, you cannot get a result. So you have to wait till the termination of the algorithm. But there are some applications, there are some requirements where you don't have much time to wait till the termination of the algorithm. So what you can do, you have to take some values in between. So that's why the existing dynamic programming has been modified by my PhD scholar to make it as anytime dynamic programming, which will always return a coalition structure. But that may not be as good as the optimal result, but it will return a coalition structure. That is the beauty. Okay, so for example, suppose this is the case when we need the result. We have, you see, we have not completed the algorithm. এই অবস্থায় আমার রেজাল্ট চাই। I don't want to wait further. I need result immediately. What should I do? You take any values 1, 2. So what will be the best combination for 1, 2? 1 and 2 work separately, and the value is 70. Right?
Yes.
Now, what is the complement of 1, 2? Because I have 4 agent 1, 2, 3, 4. What is the complement of 1, 2?
3, 4. Sir.
3, 4. 3, 4. So take 1, 2 from here and 3, 4. What is the best for 3, 4?
80. 3, 4.
80. And how do you get it?
3, 4 combined.
3, 4 combined. So my answer will be
150.
70 plus 80. And the coalition will be
1, 2 separately, and then 3, 4.
one separately, 2 separately, 3, 4 together.
Yes.
Right?
Yes.
I can start at any point of time to get the result. Size. You take the best, you take any values from here. And the best out of these 3. So best out of these 3 is 120. To take the best out of it and its complement.
And its complement. Yes.
You should not take 2, 3, 4 because 2, 3, 4 is less than of 1 to 4. So if you take 1 to 4, what is its complement? The complement is 3. That is the idea. So you don't need to wait till the termination of the algorithm. But here you see the value is 120 and 3 is 25. So 120 plus 25, it gives you the result as 145. 145. And the answer is, the grouping is 3 will be working separately, 1 to 4 will be working together, and the result is 145. Right?
But sir,
So,
this is also not given the optimum, may not be optimum result.
yes, that I'm telling. It is not optimal because it is giving us 145 and our optimal result was
150.
150. But to get 150, we need to wait the
Up to last.
But if suppose we don't have much time, আমাদের 3 দিন ওয়েট করার মতো টাইম নেই, but or my application demands immediate result. My application demands immediate result. For that case, you can go for any time.
Got it. Yeah.
Okay. So that is the idea of anytime and dynamic programming. Now, another works, one of my PhD student worked on parallel processing of the dynamic algorithm. She says that once the one-size coalition is completed, this two-size coalition can be executed simultaneously. Once the two-size coalition is completed, all the three-size coalition can be executed simultaneously because they don't have any dependency relations. The example that I have given, putting the socks and shoes on the same leg cannot be done together at the same time because there is a dependency relation. Unless you put the socks, you cannot put the shoes. But putting the socks in one leg and putting the shoes in another leg can be done simultaneously. They are independent tasks. Putting the socks and shoes and putting the food in her mouth can be done simultaneously because two independent tasks. So what we have seen that execution of these two-size coalition is independent with each other. Here you see, while I am calculating this 1, 2, and while I am calculating 1, 3, they are not dependent with each other because to calculate 1, 2, I am taking the values from one size coalition. Computing 1, 3, we are taking the values from one size coalition. So they in between, they are not dependent on each other. they can be executed simultaneously. So what we did, this is the idea. Sub problem of size 1, one size coalition, each of the agent will be working 1, 1, 1, 1, 1 separately. Sub problem 2, two size coalition. Two size coalition. So this two size coalition will be working together. Then three size coalition can work together. Similarly, four size coalition can work together. So the idea is, after a sub problem of size k is solved, solution to some sub problem of k plus 1 is possible, because this computation is independent of this computation. This computation is independent of this computation. This task can be executed simultaneously. They don't have any dependency relationship. So that will give you faster result. But the problem is, as it is an exponential number of sub problems may be resolved simultaneously, so you need to high computation device, high computation machine, because you want to go for parallel processing. And as you are going to parallelly processing, so you need to parallel architecture. Otherwise, that will be the hardware architecture will be the bottleneck for your computation. Okay. Yeah, this. So here it is given. Another one is the heuristic. And why heuristic? Due to exponential nature of the problem, using DP is feasible since the number of solution often grows exponentially, and the growth is, there's a proof in our paper how this exponential growth come order of n to the power n with the size of the problem. Here, those people who are listening very sincerely are understanding the idea. For 25 agents, mind it, for 25 agents, the possible number of coalition structure is this. You can imagine the growth.
So what does heuristic means?
Heuristic is one of the idea, or one of the, one of the type of algorithms in algorithm subjects, where you can start your computation in any place. There is no as such logic why you did this thing. You know, this may give a result. It may be a good result, it may be a bad result, but you know that this is an approach where you can get a result. There is no, for example, for dynamic programming, you are starting from a point, one size, then two size, then three size, then four size. But for heuristic, you are just jumping on a particular type of solutions. It may give you a good result, it may not give you a good result. So let us take the idea of here. It starts for coalition. It starts with a random coalition structure. कोई भी एक ले लो, and there is no reason why you take this one. So out of the existing coalition structure, कोई भी एक उठा लो. Then the algorithm creates a neighbor set of the CS using some operators. The operators can be different operators, just like we have arithmetic shift operation in the first year. I think some people can remember. So shift operation or speed operation. So to do this type of operation and try to find out that what is the result. This may be a good result, this may be a good result. This procedure is repeated for a certain number of iterations. You take anything, 1, 2, 3, 4. Instead of that, you can also take 1, 2, then 3, 4. Or 1 separately, 2, 3, 4. Or 4 separately, 1, 2, 3. Kuch bhi le sakte ho. Even you can take at your own choice. I can take my own choice. And so obviously the result will be different. We cannot expect the same result. For dynamic programming or anytime dynamic programming, if I am sitting at Durgapur and you sitting at Ramgarh, we start computing at my own pen and paper. After certain iteration, we will be getting the same result. Our result will be same. But if you go for heuristic, my starting point and your starting point may be different. The 99% chance that it will be different, because I may be choosing one of the collision structure, you may be choosing one of the collision structure, your sir may be choosing another collision structure, and will be performing the operation, and that may give result. So it's for this example, we have taken 1, 2, 3, 4 as collision structure. Then we are performing some kind of splitting operation. Instead of splitting operation, you may take some other operation. Why we are splitting? 1 को सेपरेट कर दिया, 2, 3, 4 को एक साथ रख दिया, 1, 2 को सेपरेट कर दिया, 3, 4 को एक साथ रख दिया, 2 को सेपरेट कर दिया, 1, 3, 4 को एक साथ रख दिया, 3 को सेपरेट कर दिया, 1, 2, 4 को एक साथ रख दिया. So anything and find the values of it. So this type of performance, and choose one of them. Out of this splitting, again you start from any one of this. You can choose here, I can choose here, your sir can choose here, and do the same operation again. And at the bottom, you will get the result. That result will be the value for that particular collision structure. So there can be split operation, there can be merge operation, shift operation. Even there can be a amalgamation of 2 operations. First split, then shift. First shift, then split. Anything you can do. So there is no hard and fast guideline that you have to do like this way. So that's why you may be getting a result, I may be getting a result, and our result will be different. Now, some issues with collision structure. So far, whatever we discussed for collision structure in multi-agent system, we consider that all my agents are homogeneous. That means their properties, their behavior are homogeneous. But in reality, the agent can be heterogeneous as well, where the properties, requirement, constraint will be different from one agent to another agent. Okay, what is heterogeneity? Here, Jharkhand government and Techno India are 2 heterogeneous entities. Jharkhand government has land, they have basic infrastructure. On the Techno India, they have an educational experience also. So they are heterogeneous in nature. But whatever we discussed so far is a homogeneous entities or homogeneous agent. But in reality, the agents are heterogeneous. And in that case, the forming the collision structure generation is a huge complication. All entities of the environment are identical. They all will have the similar properties. Suppose agent A1 has property set P1 and agent 2 has property set P2. Then P1 and P2 will be same. But if it is a heterogeneous, they are separate group of agents. Their requirement, their constraint, their properties, their skill set are different. They have some restriction. I'm not ready to work with you. Only some of the agents are eligible for a certain task. Some agents may have certain capability or skill set. Some may not have. For example, your institute wants to participate in a inter-institute football tournament. Will you choose 11 student arbitrarily? Definitely no. because choosing that 11 student, there may be some student who never plays football. So you have to choose those students who have the skill set football. Among the skill set, you have some plan that one will work as a goalkeeper, one will work as a defender, one will work as a midfielder or something like that. So accordingly, you need to find out such skill set among 11 students. So that's why they are heterogeneous. So your requirement is an heterogeneous team of students. Homogeneous student, because if you choose 11 students, all 11 students are of goalkeeper type. Can they bring a trophy for your institute? Never. So there are a lot of examples for heterogeneity. Electricity marketplace, yesterday I have given one example, and task allocation problem. Typically, one of my PhD is working on agricultural cooperative. So I belongs to, actually, originally I belongs to Jharkhand, and a very native place of the agricultural land in Dumka district. Now it is Jamtara district. So I have been motivated by this idea of agricultural cooperative formation through some kind of computation. So I have given this task to one of my students. She is working on this heterogeneous team formation for agricultural cooperative. Okay, so here you see the example, see the diagram. You will find out what are the different stakeholders in agricultural cooperative. Maybe typically in India, money lenders, effective logistic, environment. All the environments in India are not same. Farmers, actors in food value chain, all the together forming some kind of coalition and collaboration among actors, such that it can give the maximum profit from agricultural sector. That is our objective. So our objective is to form a coalition of diverse team of stakeholders of agricultural domain, such that when they join hands, their total payoff will be the maximize. That is our objective. So one of the students is working on this domain. Here the heterogeneity in agricultural domain. Farmers should be categorized on the basis of their production capability. In India, there are different types of farmer. If you see the native places of India, you will find very small to small farmers, medium scale farmers, large farmers. They could be categorized on the basis of crops also. Some farmers are very much efficient to produce. I mean, they have a lot of experience of producing paddy. On the other hand, some farmers may have experience of producing sugarcane, sugar tree. This. So that is the heterogeneity. Their land also is of heterogeneous. The land of Jharkhand and the land of Haryana are different. Usually the agricultural cooperative consists of large scale stakeholders. Moreover, a large scale cooperative with heterogeneous stakeholder includes more complexity. Designing a function to calculate the coalition value is crucial, as I said at the beginning of the today's discussion, that finding the coalition value, that characteristic function, is itself a crucial task. Stability, fair division of the revenue. After the coalition structure generation is created, the product is produced, the profit out of it, how will you distribute the profit among the agents such that everyone will be interested to work more in the next year? So fair division of revenue that a cooperative earns must be divided among the members in fair manner. The fair division of revenue ensures stability of the system. The fair division of the revenue ensures stability of the system. because you want to run this system for long run. Okay, so this is all about from my end. If you have any questions, we can have discussion. Hello, boss.
Anybody have any questions? I think I have told earlier that a question answer session will be there today.
Yeah, sure.
So any type of questions, please ask to sir. Anyone from student side, anyone from faculty side? Anyone from student side, anyone from faculty side?
And all the associated papers, for those today's presentation and yesterday and day before yesterday, particularly the DCOP, CSE, DCOP, and coalition papers, all papers are in my website link. You can take this from website, and still if you cannot find out or if you cannot download from your place those papers, you just send me an email. I will forward all those papers to you. Okay. If you have any
very kind of you, sir. Very kind of you.
If you have any interest on a particular problem, maybe coalition, maybe DCOP, maybe scheduling problem, like that. So you just if you can find out from my webpage, it's fine. If you cannot, just let me know. I will forward that paper. Anytime you just send me a mail that please forward this paper to my email, I will forward it. Okay.
Okay, any questions, please, everyone? No question? Okay, sir. I have one question.
Yeah, sure.
That is, you have already covered all these topics, but again, this particular part I want actually. That is stability. Yeah, this stability is mandatory for these challenges, is or for all for these agents must have this stability problem, or this particular area or particular problem have these particular things?
Two of my PhD scholars are so one, as I said, typically two PhD scholars were working on this particular domain. So one of them already completed the Narayan. So Narayan works on a very algorithmic perspective. Okay. And his assumption was that he is considering all the agents as cooperative agents. That means they are ready to cooperate. All the agents are homogeneous. That means they have all the similar skill set.
Okay.
Okay. He assumes that my characteristics function game is already given. The values are already given.
Okay.
His objective was to minimize the computational complexity. Okay. That was his job. He did. There was a very good paper with him. But I want to take this problem in some more complicated areas. For example, what I personally feel that the coalition is not limited within just pen and paper or within just computational point of view. There are more to do there. For example, in real life, the agents are heterogeneous. For example, tomorrow you may be forming some, there are already some coalition with among the TechWeek colleges and NIT Durgapur, I think. I should not reiterate it. So here you see the NPIU already formed a coalition that there are some engineering colleges they are either working with some established NIT or IITs such that these engineering colleges has lot of young faculties who just completed their MTech and joined there as a fresh candidate. On the other hand, NITs or IITs, they have a very long years of legacy of doing research. They already got funded from TechWeek 1 and TechWeek 2. So why not use NITs to act as a mentor for those faculty members of these engineering colleges? Now, after forming this type of NPIU, this type of issues, if the coalition starts, now there is something beyond the pen and paper that your college administration started not cooperating with you, such that you are, though it is written that you will be allowed to do your PhD in some IITs or NITs or ISM, but you are not allowed to release, maybe for 1 day or 2 days, or you are not giving that space to work. So you will be distracted because you have been selected under this NPIU faculty that you join here with this salary and you will be allowed to pursue your PhD under QIP or TechUIP. So this system will be unstable. People will not be happy. Faculty will not be happy. If the faculty are not happy, the student will not be happy. If the students are not happy, faculties are not happy, the institute will not be happy. If the institute is not happy, the administration will not be happy. If the administration and institute is not happy, the government will not be happy with that institute. So entirely unstable situation will be arises. So we think that while forming coalition with the heterogeneous agent, stability could be one of the metric to check whether your system is stable or the system you are trying to design will be a stable system or an unstable system.
Okay, sir.
Jodio, still we have not defined any metric value. I mean, the expression for stability. Still we are working. Okay, still we are working.
So
the stability.
Not only this stability, heterogeneity, large scale, collision value, all are these matrices.
Yes. And not only that, stability will be different from different application domain.
Okay.
For example, another example, very good example. Just wait. In number of occasions in Parliament, we have seen that some of the alliance party have taken their support. Have you seen this? I mean,
yes.
It happens in number of occasions in India that you have given the vote. There was a coalition government in Parliament. I mean, in Delhi, and after 6 months or so, there was a chaos in the alliance. Some of the local parties took their support. So that is the stability. But how to make that stability metric is, of course, again a difficult task. It's not so easy.
Okay, sir. So anybody don't have any question? I think anybody have any question? Again, this is also another chance to ask these questions. Anybody have?
If the faculty members want to interact, they can also interact even after the students. If you think so, you can leave the student, then we can have a discussion also. If you think so.
Okay, if you don't have any question, then the people who have really learned And sir,
I have a question.
yes, question.
Good morning, sir.
Yeah, please.
Sir, what will be the time and complexity of the anytime dynamic programming? Sir, please.
Your voice is not audible.
Sir, I already had text information.
Okay, you can write in the chat box. I think this is unaudible. You can write it in chat box. Please.
Yes, sir. I already have written it.
কি লিখেছে দেখো তো?
I think, sir, in chat box it is written. Please.
Chat box. Chat box है.
Sir, below participants, just after beside the participants list, not above, sir, not above.
Below.
Beside participant list.
Security, stop videos, news share. না তো মেসেজ আমি দেখতে পাচ্ছি না কি লিখেছে বলো না তুমি বলো
Sir, I cannot see because I am not host. Sir, নিচে দেখুন participant যেখানে আছে নিচে দেখুন মানে স্ক্রিনটার নিচে participants তার পাশে চ্যাট আছে অপশন আছে স্ক্রিনের নিচে স্ক্রিন স্যার স্ক্রিনের
নিচে তো কিছু নেই ওকে না এটা আমার লিনাক্সটা খুলে গেল স্টপ ভিডিও আনফরচুনেট ব্যাপারটা
এখানে মিউট অর স্টপ ভিডিওর অপশনটা আছে
হ্যাঁ
তার পাশে দেখুন চ্যাট পার্টিসিপেন্ট চ্যাট শেয়ার এর পাশে
মানে এটা হচ্ছে না কেন মিউট এই অপশনটা দেখতে পাচ্ছি না দাঁড়ান আমি স্ক্রিনটা
ওকে দেব ক্যান ইউ রিপিট
I can check a page. Okay. Sir, what will be the time complexity of any time dynamic as well as space complexity too? Okay. See, I can give you the values, but if you need, you just send me a mail. Dev. Hello.
Dev is there? Yes, Dev is there, I think.
Yeah, you please send me your email. I will forward the exact paper. Okay? Because I have the entire paper of anytime dynamic algorithm.
Okay, it is Dev.
Okay.
Okay, sir. Actually, he is unable to tell, I think.
Okay, no problem. So you just send. I'm just writing. Please. I will forward the paper. Okay, I will send him the paper. Okay, anything else?
Okay, sir. Now, from student side, you want to share any experience of this 5-day webinar who have learned a lot? That I expect that type of students, and please share your view on that particular webinar. Anybody want to share? Anybody want to share any kind of view about this webinar?
Yes, sir. Hello.
Hi, hello.
Yes, sir. I'm Nayan Sarkar. I'm from Assam.
আচ্ছা হ্যাঁ তুমি ফোন করো মেসেজ
হ্যাঁ স্যার রিগার্ডিং দ্য এক্সপিরিয়েন্স আমি এটাই বলতে চাই যে আমার জন্য রামগড় ইঞ্জিনিয়ারিং কলেজের একজন ফ্যাকাল্টি অসীম কুমার মাহাতো উনি আমাকে লিংক দিয়েছিলেন রেজিস্টারের জন্য।
আচ্ছা
তো
বাহ।
রেজিস্টার করার পর যা প্রথম যেটা এমন একটা মাইন্ডসেট ছিল আমার যে লগ ইন করে রাখি, রেজিস্টার করে রাখবো, কিন্তু যখনই আপনার প্রথম 5 মিনিটস শুনলাম, তো শোনার পরে আমি আমার ফুল মানে যতদূর পেরেছি আমি নিজের বেস্ট দিয়ে শোনার বা বোঝার চেষ্টা করেছি।
আচ্ছা আচ্ছা।
আমার জন্য টোটালি একটা নতুন প্ল্যাটফর্ম, নতুন ডোমেইন, এজেন্ট এন্ড অল। তো খুবই ভালো লাগলো, আমি খুব শিখতে পারিনি বলবো, মানে যা বুঝেছি এটলিস্ট একটা প্ল্যাটফর্ম পেয়েছি, একটা ওয়ে পেয়েছি। আপনি যেভাবে মেটেরিয়ালস গুলো মানে যেভাবে ডেসক্রাইব করেছেন, বা তারপর যেই জিনিসগুলো, যে কিছু কিছু জিনিস আপনি যেমন যে পেপারের ডিটেলস গুলো আমাদেরকে, বা যদি আমরা যদি মেইল আমরা যদি ডাউনলোড
শিওর
করতে
শিওর,
না
এটা
পারি
নিয়ে কোনো
আপনি
বলারই অপেক্ষা
দিয়ে
রাখে
দিবেন।
না।
তো স্যার
আমি আজকের যে স্লাইডটা, আমি আজকের স্লাইডটা পাঠিয়ে দিচ্ছি, জাস্ট
হ্যাঁ স্যার,
ওয়েট করো, আমি
ঠিক
এক্ষুনি
আছে স্যার, অলরেডি আমরা স্লাইডস কিছু পেয়েছি, ভাস্কর স্যার অলরেডি দিয়েও দিয়েছেন।
হ্যাঁ, ওই আগের দিনের গুলো, আর আজকেরটা আমি দিয়ে দিচ্ছি এক্ষুনি।
হ্যাঁ স্যার, তো এটাই বলবো যে একটা নতুন অভিজ্ঞতা পেয়েছি, অনেক মোটামুটি অনেক জিনিস মানে নতুন একটা স্বাদ পেয়েছি বলবো, অনেক শিখতে
আচ্ছা।
পেরেছি, আরো হয়তো নিজেকে আরো ট্রাই করব যে আপনার সঙ্গে কন্ট্যাক্ট করে আরেকটু নিজেকে আপডেট
শিওর
করার
শিওর
জন্য।
হ্যাঁ।
এন্ড
না
আই
যদি
ওয়ান্ট টু,
এই,
হ্যাঁ স্যার,
হ্যাঁ বলো 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 বলো।
আমার একটা খারাপ লাগলো, গতকাল আমি অ্যাবসেন্ট ছিলাম, তো সেটা আমি মিস করেছি
ও
গতকালের সেশনটা। হ্যাঁ, তো এনিওয়ে আপনার স্লাইডস থেকে আমি ওগুলি পড়ে নিব একটু, আর হয়তো পরে আপনার
আচ্ছা,
সঙ্গে বা বাকিদের সঙ্গে
ঠিক
কথা
আছে।
হবে।
হ্যাঁ, মানে যদি কারোর কোনো রকম কোনো জিজ্ঞাসা থাকে, যেহেতু আমরা এটাতে কাজ করছি এখন প্রেজেন্টলি,
স্যার
এবং I have a very good collaboration in this particular area with a French university, University of Claude Bernard University Lyon 1 প্যারিসে। তো ওখানে এক ভদ্রলোক আছেন, তার সঙ্গে আমরা জয়েন্টলি কাজকর্মগুলো করি, ঠিক আছে? সেখানে আমরা জয়েন্টলি কাজকর্মগুলো করি, আমার ম্যাক্সিমাম পেপারই দেখবে ওনার সঙ্গে রয়েছে। তো ইনফ্যাক্ট ওই যে ছেলেটি আমার ছাত্র থিসিস সাবমিট করলো, নারায়ণ, ও জয়েন্টলি করেছে ওনার সঙ্গে কাজ। তো দেখতে পারো, এবং ওনারও ওনার ওই ভদ্রলোকেরও প্রচুর কিছু পেপার রয়েছে সেপারেটলি আমাদের ছাড়াও আরো, মানে ইটস এ বিগ ডোমেন। আর যদি কেউ মনে করো, ইফ ইউ রিয়েলি ফিল দ্যাট দিস এরিয়া ইজ রিয়েলি ইন্টারেস্টিং ফর ইউ or to explore, the best place to start your journey is AMAS conference, AAMAS.
আচ্ছা
AMAS conferences paper gulo sob freely available, you don't need to purchase, you don't need to have any kind of registration, anything.
আচ্ছা
Okay, so
sir.
from the beginning of the conference, all the papers are available on their site, you just go and download.
Sir,
There are lot of research component that is given on their site. What are the recent research component on agent and multi-agent system, that is also there. So I just discussed two of the research component or research areas where typically we are working, or our team works. One is DCOP, DSP and all, and another is coalition structure. But apart from these two areas, there are a lot of other areas where people are also working on agent and multi-agent system. Maybe this sensor network, maybe ad hoc network, radio frequency, lot of issues. Okay, so if you think you can explore those conference websites, you will be getting a lot of information from there.
থ্যাংক ইউ স্যার। আর স্যার আরেকটা জিনিস যেটা শিখতে পেরেছি আপনার থেকে, কি করে প্রেজেন্ট করতে হয় বা মানুষকে কি করে
না না না, সেরকম কিছু ব্যাপার না।
আমি এই প্রফেশনে আছি কিন্তু এত তো জানি না, আমরা ভেরি ফ্রেশ, ভেরি নিউ, তো আপনার থেকে সেই জিনিসটা শিখলাম।
না না, সেরকম কিছু ব্যাপার না, করতে করতে হয়। আর সবচেয়ে বড় ব্যাপার যেটা হচ্ছে যে মানে আমি তো মানে আমারও সত্যি কথা বলতে কি, এই অনলাইনে দেওয়ার অভিজ্ঞতা খুব কম। হ্যাঁ, মানে আমি খুব মানে হেটই করি বলতে পারো, কারণ আমার কাছে মনে হয় যে পার্টিসিপেন্ট আর স্টুডেন্ট, মানে আমি স্টুডেন্ট হিসেবেই বলি, হ্যাঁ, মানে তাদের সঙ্গে এক ক্লাসে আড্ডা মারতে মারতে পড়ানোটা হবে খেলার ছলে, মানে ঠিক পড়ানো হবে কেন, মানে এইটাতে আমার আপত্তি, আমার কতগুলো রয়েছে, মানে প্রেজুডিস রয়েছে, যে পড়ানো হবে কেন, পড়ানোটা হবে খেলা। মানে আমি যদি দুটো কথা বলি, স্টুডেন্টরা 10টা এমটেকের বা বিটেক।
হ্যাঁ স্যার,
বলো
না বলছি আপনিও আমাদের জন্য সেম প্ল্যাটফর্ম ক্রিয়েট করে দিয়েছেন, যে মানে ক্লাসে যেরকম এনভায়রনমেন্ট হয় আপনি এখানেও আমাদেরকে,
এটা হয়তো এখানে তো অতটা ধরো সবাই নেটওয়ার্ক ব্যান্ডউইথ পাচ্ছিল না, বা অনেকে হয়তো সাই ফিল করছিল, এগুলো বুঝতে পারলাম আমি নিজেও। হ্যাঁ, তো অনেকে হয়তো বিটেক এর স্টুডেন্ট ছিল, তাদের পক্ষে একটু হয়তো মনে হচ্ছিল যে অ্যালগরিদমের জায়গাটা হয়তো একটু কমপ্লিকেটেড হয়ে যাচ্ছে, সেটা আমি ফিল করছিলাম। আমি চেষ্টা করছিলাম ওই জন্য যতটা এক্সাম্পল দিয়ে দিয়ে বোঝানো যায় ব্যাপারগুলো।
And that is
যেমন আজকে
that is my concern, sir. Sir, whatever you have given example, that really creates example for us. Okay.
যেটা আমার মনে হচ্ছে যে কোয়ালিশনের সবচেয়ে মানে why should I use the example of Flipkart and Amazon? Why should I use the example of something else? Because there is a good example of coalition is the Jharkhand government, Jharkhand Education Department and Techno India.
That's why whatever example I have given, and even in Amisha's question, if why this performance is decreasing, and
Performance is decreasing.
I cannot expect that this type of example you can give, and whatever you give, that is truly amazing.
এবং হ্যাঁ এখানে আমি আরেকটা জিনিস তোমাদেরকে পয়েন্ট আউট করব, মানে I will be sharing my experience as you people are sharing. So all are computer science people, right?
Yes, sir. Yes.
All are computer science people. The students, the faculties, all are computer science. I think this is my personal feelings that each and everything of computer science theory comes from human society. The best example of semaphore, the best example of semaphore, binary semaphore, I think many of you teach operating system. The best example that I use in the class, use of toilet in the hostel. Okay, so if you give this type of example, I think the people will be, because in toilet door there are two mode, either it will be locked from inside or it will be locked from outside. The semaphore value as S can be either 0 or 1.
Yes.
If the toilet door is locked from inside, be allowed to enter. If it is lock is from outside, nobody is there, you can enter. So I mean we have to make, I mean as a whole, I'm not telling everybody should, as a faculty we should try to make the class as enjoyable as possible. ক্লাসটাকে যদি আমরা এরকম ভাবে একটু ভাবতে পারি যে স্টুডেন্টরা কিন্তু মানে একটু খেলার ছলে ব্যাপারটাকে যদি আমরা করতে পারি, তাহলে আমার মনে হয় অনেকটা বেটার হয়, স্টুডেন্টদের পক্ষে চাপটা অনেক কম হয়।
Yes. মানে definitely sir, we will try, we will learn a lot.
হ্যাঁ মানে এটা তো ইঞ্জিনিয়ারিং সাবজেক্ট, তো পুরোটাই কিন্তু কনসেপশনের উপর দাঁড়িয়ে আছে, পুরো জিনিসটা কিন্তু কনসেপশনের উপর দাঁড়িয়ে আছে।
Okay, any students from student side, I would expect any experience you can share, and language is not a bar, I think, sir.
Yeah, sure.
We are talking in Bengali, and most of you are in Hindi, from Hindi background.
English, of course. Apart from that, I can understand the Assamia as well as Odia.
Okay.
Okay, I cannot speak, but I can understand. So
language is not a bar. So please, anybody want to share some view from student side, please share the thing. Dev.
Yes sir.
Now your voice is clear. Please share.
Yes sir, बहुत ही अच्छा लगा सर, बहुत ज्यादा अच्छा लगा, और फुल्ली 5 days जो है पूरा एंटरटेनिंग भी रहा और अच्छा लगा। हर एक जो भी चीज सर बताएं सर रियल वर्ल्ड से रिलेटेड था। तो थैंक यू अनिमेश सर, थैंक यू सो मच।
Thank you
so much.
Okay. Anybody else? Okay, then we should conclude session, and we should conclude the particular whole webinar, 5 days webinar. So special thanks to Animesh sir that he has
thank you.
he has given a lot of time and from his busy schedule. And sir, one thing, sir, what again you have come 15 minutes before starting the webinar. So that is very appreciable. Normally it not happening. Even not even participants are not joining just after starting the session, and you have started from every day I have seen that one. So that is very appreciable part from for you, and whatever you example you have given, that is very appreciable. And special thanks to my principal ma'am for
Thank you.
giving this particular opportunity to inspire us to organize this type of webinar on distributed AI and web agent technology. And again, special thanks to TechIP coordinator sir, Dr. Aditya Kumar Singh sir. He has also supported a lot for organizing it. Maybe there have a lots of tasks, another task, and that's why he cannot join today. Aditya sir already told me that he has joined. He will join, but some task may come. That's why he cannot join. And the principal ma'am is also some other task is there. So sorry for that. Anyway, sir, you cannot interact with ma'am.
No problem. I
And
have already talked with Aditya sir.
okay. And special thanks to Mr. Pijus Mandal, who is the actually we are now we are facing some internet problem in college. So in that point of view, he has arranged some other option to give this organize this particular webinar. So that's why special thanks to Pijus Mandal and all the CSE faculty members for participating this, and all the students who are entire session who have attended that particular thing. And so thanks all of you. And then sir, please again, if we need your help, I will contact to you, and again we can do another webinar with you, and hope you will enjoy and that one. Thank you.
I have already shared today's paper, today's presentation.
Okay.
And I will be sending the paper that Dev has asked me. Okay.
Okay.
It is in my hard disk. I will be sending the paper.
Okay, sir. I will. Okay, sir.
So please, for this presentation, you please circulate among your.
Yes, sir. I will send.
As that everybody got the presentation.
Okay, sir.
Okay. Thank you so much, everybody. Thank you, Nan, for connecting from Assam.
Thank you, sir.
Nayan from I think
Assam,
sir.
Assam now mone kodai ki dekhlam জানেন
স্যার নাগাল্যান্ড
নাগাল্যান্ড
আমি ওখানে কাজ করছি এখন নাগাল্যান্ডে একটা
আচ্ছা
কলেজে
ঠিক আছে থ্যাংক ইউ সো মাচ
থ্যাংক ইউ স্যার আমার একটা রিয়েলি আই এম ফরচুনেট এনাফ দ্যাট আই গট দিস অপরচুনিটি